Welcome back. In this video, we're going to learn about using variables and procedures. A variable is a spot in the microcontroller's memory where you can store information that changes during program operation. To keep track of what's stored in the memory of our virtual microcontroller, we can use the variables panel. I'll click on it here to bring it up. We're going to be using this variable, variable A. And we're going to make a simple program that counts from 1 to 10 using the variable A. We'll start with the expression command from the variables grouping. I'll drag that out and put it here. An expression is a mathematical phrase. We're going to start with a simple expression. We'll say A is equal to, and I'll just type in a 1 here. Now, if we test that, we'll keep an eye on the variable here. We'll say test. So this is what will happen when this expression is executed. A is going to be set to 1. So the value on the right side of the expression gets copied to the thing on the left. So the number 1 gets put into the variable or memory location A. And I'll say OK. And then we get this little label here, A is equal to 1. I've added 2 commands to our program. One is a wait 0.5 statement to give us a half a second between the counts in the variable panel. The other is a blank expression statement. We're going to modify this statement to add 1 to the count after every half second display. So we'll change this expression to A equals A plus, and I'll just type in a 1 here. So we're going to take the current value of A, add 1 to it, and then put it back into A. So right now from a previous program run, there's 17 in A. So if I did a test, you can see that it took 17, added 1 to it, and put it back in A to give 18. Okay, so if we close that, we get the label A equals A plus 1. After we've added 1, we'll go back and wait a half a second before we add the next count. Great, so we're ready to try the program. Let's go up and look at the run speed. I have it set for graphic run, but I don't have any kind of delay. So we'll go up and run this, and we can see our count coming along nicely at half-second intervals. I'll pause the video a little bit because otherwise it'll take a while to get to the top. The maximum number you can store in one of these variables is 255. You're going to see when it gets to 255, it'll roll over back to 0. And these are 8-bit variables. 2 raised to the power of 8 is 256. So we can store 256 different numbers in them. We have 1 to 255 plus 0. So there's only 256 different numbers that can be stored in one of these 8-bit variables. We're going to modify the program so that it only counts to 10 and then starts over again. I'll right-click under the wait statement and click on Insert Row, and then I'll do it one more time. We're going to put a compare statement in here, so I'll get that from the grouping under variables. And you'll notice it put the yes branch in right away. We want the counting to continue or do a yes if A is less than 10. So I'll type that in here. A is less than 10. So we can see the label appears here. If A is not less than 10, then we want to go back and start over again. So I'll get the pencil tool and I'll put that in. So here's our no branch. Okay, we're ready to test it. Before we do the test, I'll bring the variables pane back out again, and we'll take a look at the simulation run speed. We're going to run at about 50 milliseconds with a graphic run, and then I'll say simulate run, and there you go. It's counting, and it keeps counting because a is less than 10. Once a gets to 10, 10 is not less than 10. So we're going to get the no branch, and then it's going to go back and start all over again. So we've made our first counting program. The next program we're going to build is a variable speed light flasher. If you watch output 0, you'll see it start to flash slower as I move the A4 slider to the right. This program introduces 3 new commands from the procedures grouping: procedure, goSub, and return. A procedure is a program that the main program can call to perform repetitive tasks. The procedure command is used to indicate the start of a procedure. This procedure command is labeled delay. This delay procedure is like a custom wait statement. It produces a wait time that's controlled by A4. The return statement is used to send program control back to the main program. Program control returns to the command after the command that jumped to or called the procedure. The command that calls or jumps to the procedure is the goSub command. goSub stands for go to subroutine. A subroutine is just another name for a procedure. The goSub commands in our main program are labeled delay, and the procedure command in the procedure is also labeled delay. But you'll notice that the goSub command has a solid line on both sides, whereas the two commands used in the procedure and return, have dotted lines on both sides. I won't go through the entire construction of the program since you should be pretty familiar with editing in Logicator, since you have been doing all the examples. You have been doing all the examples, I hope. So instead of showing you the construction of the whole program, I'll show you how to set up the new commands. When you bring out your procedure command to start off your procedure, it has no label. If you double click on it, you can give your procedure a name. So I'll call this procedure delay, and I'll click OK. And then I'm going to connect my procedure command to the procedure. The return command is placed at the end of the procedure, and it doesn't need to have any information entered into it. Just place it in your procedure when you want it to return to the main program. Once you've created your procedure, between the procedure statement and the return statement, you can get your goSubs to point to your procedure. So if I double click on this goSub, I'll have a list of procedures that I can choose from. In my case, I only have one procedure, so I'll select delay, and I'll say OK. And then we'll do the same thing with the other goSub. We'll say OK. So what it'll do is it'll put 0 high, it'll call the delay, put 0 low, call the delay, and so on. OK, we're ready to test the program. I'll set my A4 slider to 2, and I'll set my simulation speed to about 4 ticks to the right. Here I have 338 milliseconds and graphic run, and I'll click OK. In this simulation, we're not going to look at the details of how the procedure works. Instead, we're going to look at how the main program and the procedure interact. I'll start the simulation now, and we can see the light comes on, and we jump to the delay. It's going to waste some time in the delay. When we get to the return, we're going to return to here, the cell after the cell where the delay was called. So we return to here, turn the light off, jump back into the delay. We're going to waste some time. Once the delay is done, we'll jump back to here. the cell after the delay. And then we go back, turn on the light, and we'll start it all over again. Let's take a look at the delay subroutine in detail. I used an expression statement to copy the value from the analog sensor A4 into a variable D. I chose the D variable because it could stand for delay. I've also added 1 to the value of the sensor to deal with the case of the sensor having a value of 0. The procedure keeps subtracting 1 from D until D has a value of 0. 0 is not greater than 0, so the compare statement takes the no option and we return back to the main program. Naturally, as we increase the slider to the right, A4 gets bigger, so D gets bigger, and it takes longer for it to count down to 0. And that way we can control the delay. Some of you will be asking why I needed to avoid a value of 0 from the sensor by adding 1. Let's change this compare. I'll go into this cell and I'll just type a space, and I'll type a space, and we'll say OK. And now we have D equals A4, so we can see what happens when we get a 0. Before I start the simulation, I want to make sure the slider is set for 0. So analog 4 is 0. Once the main program calls the delay, the value 0 is going to be transferred to D, and it will show up here in the variables pane. When we subtract 1 from D, we would expect to get 0 minus 1 will give us negative 1. Let's run the simulation and see what we get. I'll go up to Simulate, and we call the sub. D is 0, and now we subtract 1, and it becomes 255 instead of minus 1. So now we have to count down all the way from 255 instead of from 0. So we're getting a long delay instead of a short delay. So what's up with that? Many of you will recall from a previous video that the range of a variable in logicator is 0 to 255. If we try to drive a variable below 0, it rolls around to the highest value, which is 255, and continues to count down from there. In this case, if D is 1 and we subtract 3, we need to count backwards 3 times. So if I count backwards 3 times below 1, I get 0, 255, 254. Let's try it and see what we get. Okay, it works. The same thing is true in the positive direction. When you count past 255, the value goes to the lowest value, 0, and counts from there. If I add 5 to 253, I'll count 5 times past 253, and I'll get 254, 255, 0, 1, and 2. Let's try that out. Good, it works. It's a good idea for you to try a few examples of your own. If you understand the range of variables and what happens when you overflow them, it'll be a lot easier for you to find problems with your programs.